So we've already solved absolute values already. We've already solved inequalities. So this is just a combination of the two. Okay? So we solve similar to solving absolute value equations. So there's going to be two inequalities in a problem, creating a compound inequality. And then we need to graph your solution on a number line. Okay, which is number line, not graphing. Okay? So how we do this, we get the absolute value by itself on the left side, just like we did last night. Okay, then we break the problem into two inequalities. This is the part that's very important. So if it is greater than or equal to, so greater than or equal to, it creates a union or an or, and I'll explain that more. We've already done inequalities, but so there's going to be two separate problems. Okay? If it is less than or equal to, it creates an intersection or an and. So it's going to be one problem. Okay? So remember where there's like the problem in the middle and there's two inequalities on either side. So we want to make sure that there is a positive and a negative answer. And then we solve the compound inequality, like how we solved compound inequalities beforehand. And then we graph our solution. When we have our negative one, we need to make sure that we reverse the inequality sign because it's kind of like multiplying by a negative number. Okay? So you want to make sure that the pointy part or the mouth is pointing the opposite direction. Okay, so let's try this. What? Okay, so this is a less than, so it's a and problem. So it's going to have it's going to be a intersection, so it's going to be one problem. So I'm going to have one that's a -3. I like doing my negative on my left side because it makes it easier when I'm graphing. And then my sign, right now the big part's touching the 3, so the little part needs to touch the 3. Okay? Then I'm going to have x minus 4, and then my less than 3. Okay? Now I'm just going to solve like how we solved inequalities beforehand. So I'm going to add my 4 to both sides. So -3 plus 4 is 1. Then 3 plus 4 is 7. So this would be my answer. And then now we're going to graph it, or on a number line. So I'm going to have an open circle at 1 and an open circle at 7, because remember that it's not equal to, and then in between. Okay? So this one is greater than or equal to, so it's going to be a or, but I don't have my absolute value by itself yet. So I'm going to add 2 to both sides. So I'm going to get the absolute value of 2x plus 5 is greater than or equal to 9. Okay. So this one is kind of just like how we solved the problems last night. We're just going to set up two problems. The main part, though, is that our negative number, our -9, we need to flip our sign. Okay, so I'm going to have 2x plus 5, which is less than or equal to -9. And then 2x plus 5 is greater than or equal to 9, because there's going to be two answers. Okay, and then we just solve like we did beforehand. So I'm going to subtract 5 and get 2x is less than or equal to -14. Divide by 2. X is less than or equal to -7. Now let's do the same over here. So 2x is greater than or equal to 4 divided by 2. X is greater than or equal to 2. So then I'll have my number line. We're at -7, so somewhere right here, and this is going to be a closed circle because it's equal to, and 2, okay, and, oh, they're opposite directions, sorry. Resend. Go somewhere else. Okay. So it's not exactly hard, it's just remembering which sign. If it's less than, it becomes 1. If it's greater than, then it's 2. Okay? Let's try 2 more. Okay, so we have 3x minus 1, or the absolute value of 3x minus 1 plus 2 is greater than 4. So what do I need to do first? I need to do my inequality by itself, so how can I do that? Subtract 2. Alright, so the absolute value of 3x minus 1 is greater than 2. So is this going to be an and or an or? Is it greater than?
Yeah.
It's greater than, so it's an or. If it's greater than or equal to or greater than, then it's or. If it's less than or less than or equal to, then it's an and. This is an or, so I'm going to have 3x minus 1, which is less than negative 2. So we're going to flip our sign with our negative. And 3x minus 1, which is greater than 2. And then we solve, so I'm going to add 1. So I get 3x, which is less than negative 1, divided by 3. X is less than negative 1/3. Then we do the same over here. X is greater than 1. So our number line so we'll have negative 1/3, which is somewhere around like here, and 1, which is somewhere around there. And these are open circles because they are not equal to. And then it is x is less than and greater than. One. So what do I need to do first? Add 3 to both sides, right? So I get the absolute value of 2x plus 1 is less than or equal to 9. So this is a less than or equal to, so it's a and. So it means it's going to be going together. Okay, so I'm going to have one long inequality. And so I'm going to have a negative 9. You have to do the negative of the sign. Remember, you flip the sign. So right now you see that the mouth is eating the 9. I know it kind of sounds weird, but my little monster here is eating my 9. So now I need the other way. My pointy part, my less than part, is going to be pointing towards my 9. Even though it looks the same direction, but it's not technically. Okay, then it's 2x plus 1, and then have our 9. Okay, and then we just solve. So I'm going to subtract 1, but I have to subtract 1 from all sides. So this will be negative 10, 2x, and 8. Divide by 2, negative 5, x, and 4. So then we have our graph, our number line. And it is at negative 5 and negative 4, and these are closed circles. And because it's a and, goes together. Ors can overlap each other, they can go in opposite directions, but ands always end, okay, or towards each other. Like these ones, if this something made this sign flip, it could make them go towards each other. Okay, so let's try some word problems. Okay, you ready for this? So, formula that you can use to solve absolute value word problems will be x minus the average, and then we're going to have our inequality sign there, and then our tolerance. The only inequality signs that we're going to be using are less than or equal to. So that's going to be our and. So we're going to have that. So let's try some. So a cereal manufacturer has a tolerance of 0.75 ounces for a box of cereal that is supposed to weigh 20 ounces, right? And solve an absolute value inequality. Describe the acceptable weight for a 20-ounce box of cereal. So we're going to have we're going to create an inequality, and then we're going to solve it, which will tell us our domain, our range. So my equation was x minus my average. So what is my average? 20. This tells me my tolerance is 0.7. Okay, sorry, not equals. So we're always going to have either less than or equal to, so it can equal the largest amount, so it's less than or equal to. If it is just less than, it will tell you less than, okay? So now we're just going to solve. So this is going to be an and, so I'm going to have negative 0.75 on one side. Remember, my sign needs to flip. Then x minus 20. And then I'm just going to add 20 to both sides. So I get 19.25 and 20.75. So our box of cereal can weigh anywhere between 19.25 ounces and 20.75 ounces. Okay, let's try another one. So you are a quality control inspector at a bowling pin company. A regulation pin must weigh between 50 and 58 ounces, exclusive, write an absolute value inequality describing the weight of the pens. So, what? I said inclusive. I haven't said inclusive, but thank you. If I didn't say inclusive, I meant to say inclusive. Okay. So we are given the two values, the x's, okay? So I'm looking, I don't have my tolerance or my average, so I need to find those. So I need to find my average. The average is pretty easy to find. So how would I find my average of the two weights? Yes.
Add them together and divide by 2.
Yeah, so what would that be? What would be my average? What's 50 plus 58 divided by 2? So 108 divided by 2. 54. Okay. So now that I know my average, I can take one of my x's and find my tolerance. So I'm going to do, let's just say we'll start with 50 minus 54. And remember, this is an absolute value. And that's going to equal my tolerance, 19. Okay? So I'm going to get negative 4. And what is the absolute value of negative 4? 4 equals t. But let's just make sure that 54 was right. So let's try 58 as well, just to make sure. So 58 minus 54. So we will get 4. And the absolute value of 4 is 4. So we got 4 for both. So now it asks us to write the equation. It didn't ask us for the tolerance, it asked us for the equation. So I need to write my equation. The absolute value of x minus 54, and then it's going to be less than or equal to, because it can weigh that amount, 4, our tolerance. Remember that it will say less than if it is less than, and not less than or equal to. Okay, let's try one more. So write an absolute value inequality that represents all real numbers less than 4 units from 0. Okay, so 4 is going to be our tolerance. It's the furthest that we can go. And it says less than, so it's just going to be less than. And 0 is going to be our average. So it would be x minus 0, which is less than 4. But would we need the 0 there? No. So just be the absolute value of x is less than 4. Okay. There's homework on the textbook page that you should have picked up, which is 5-5 solving inequalities involving absolute values. Page 314, 315. Number 17, there was an error. The S should be a 2, so please go in and change that. If you do not have this paper, please come see me or come get one. Do you have the paper? So did you ever find your previous night? So this is, does anybody need this? You should have gotten it. That's that. It's that stapled because I don't know what happened. What?
Printed it too long.
Yeah, printed it too. Yeah. I didn't print it. But